So we're settling out somewhere around 13 or something. And now we're going to take the amp hour.
1394.
Yeah. We're going to take this, and now we're going to discharge it back at 1 amp hour, and we'll call this test 5. And now we'll have a completely different discharge curve because we brought the battery up higher yet.
This is the next circuit coming up.
Yes, this is number 3. This is number 3. This is comparator discharge. So we're going to use the comparator and we're going to discharge.
And what's this again?
Capacitor.
Okay.
So we're going to use 60,000 UF microfarads. And that's going to be these 4 caps. So now this arrangement's a little bit different hookup because this comparator is going to discharge on the negative terminal of the battery, the minus. And the positive is going to go directly to the positive of the cap.
Okay.
Okay? So this is going to sense the capacitor voltage. Okay? And it's going to tell this when to discharge, and what you're going to see here is it blink a green light. And it's going to be this same arrangement with the diode in line here. So what we're going to do, now we're going to watch this because this is negative, or negative of the battery over here. See? Black. And then this is going to be negative of the caps. And what we're going to do is remove the positive lead and put it to the capacitors. And then we're going to take the positive of the capacitors, go to the batteries, and we're going to put a current meter so you can watch the pulses and how we're able to change the time period and how much power we're going to get. So we're pretty close down to where we were. So let's start a new test and watch the charge. So we'll test 5. And now we're going to go to charge monitor. Let's call this test 6. Okay, and this is where our battery settled in. Okay. Okay, and as you can see, our settling voltage is back at 1278. Right? Now we're going to start the machine, and we're going to stair step it up with capacitive discharge. Now, as you can see here, each time it discharges, it's dumping. The meter's slow, so it's actually more than that, but that's meter's showing us about 3. Now watch. And look at the charge curve.
Yeah.
What are you seeing, Tony?
Stair steps.
Okay, now watch me change the rate. Now watch as I change the time to like lower seconds. As I build up more charge, I build up more current. See it?
That's that spike, is it?
That's what you're listening to is each time it discharges into the battery.
Yeah.
Now look at,
Oh, yeah.
So why is that happening?
that's the stair step up. That's the time that it takes to charge the capacitor and the comparator.
So why is it stair-stepping more now than it was when they...
Because I've changed the time to like once a second, see it?
Oh, okay.
And it's over 4.5 amps. If Tony looks at the meter. Actually, it's a lot higher than that. So, once again, by viewing this, right, we'll let this run till it gets to 15. And we're stair-stepping it up, but that's about once a second.
Yeah.
And so the machine is charging 60,000 microfarads of capacitance.
It's not growling, you say?
No, no, it's relieved of all that,
Yes.
of all the stress.
Is this 3 or 4 now?
Which one?
We're on 3.
Still, are we? Okay.
Yeah.
It's suddenly climbing up rapidly.
Yes.
So it's more like a forced charge now? Or
No, no, no. No, the voltage is rising and the current is going down.
Mm.
See? Because the battery is not requiring current now. You're right at 1533.
Mm-hmm.
See, now it's going to start to bend over.
Okay, because it can't take any more, right?
Right. The chemical can
Right.
absorb it. And
15.5.
Yeah.
15.5.
now, let's just show this one time. Let's just show the rates here, Tony, of our comparator. So as I go this direction, I'm going to increase the rate, and you can see that here.
Right.
But I'm going to decrease the current, see? Because I'm not letting the capacitors charge as high. So I could choose any time scale that I want.
Yeah, look what's happening on the...
Yeah, if you look at the curve, it's totally different. Here it's 16. Now watch as I increase. As the battery absorbs more charge, the meter reaction will be faster. See? See how fast it's going?
Yeah.
Yeah.
Now if you remove the diode from this, if you remove the diode, then we're under a different mode. See? Because now we're not isolated.
Mm.
So there's where I removed the diode, the little
Right.
notch, and now it's continuing to charge. And now watch the adjustments here. See, I can hold it steady at 1.25 amps,
Yeah.
or I can move the machine into a much,
It's dropping off.
yes. Why? Because it's not isolated, and it's not a forced charge. It's a
Okay.
capacitive discharge. But yeah, but it's dropping off at 16 volts, so it's boiling
Yeah.
away. So basically, those are the operations of the machine. And once again, I want to point out to you that with that device, you can choose wherever the time.
And that's what you were doing with the little adjuster?
Yes,
Okay.
with the little adjuster.
Right.
And that was in this little circuit like this. And I was tuning this
Yeah.
little pot.
With this thing.
Yeah.
Like like a little mini screwdriver.
Yeah, and I put the green light here so that you could see the flash rate of how quickly the comparator switches. Now, it's very important to remember this is not a normal comparator circuit. It's much more sophisticated, all right, than what we've drawn.
Right.
So, and it's something that we built. So, you know, they can, if they need to have this comparator, the thing about this comparator is if you feel this, Pat, you feel a heat here. Here, come here. You feel the heat here.
Oh, yeah.
Okay? That's because each time this 60,000 microfarads dumps the charge. Yeah, absolutely.
They don't feel hot.
No.
It's just that.
And either does the coil there, Phil. Now, I want to point out, when the machine runs right, you can hold these devices. Here, Pat, do you feel any heat?
No.
It's at room temperature. So, when you build the machine correctly, this is what your machine will do. And depending on how many amp hours you're going to take out of this battery is dependent on how much time it's going to take to do what we just did. So please don't change things. You know, if you have one of these machines, because it's already calculated for this device and for these kind of batteries. In other words, don't come up with a little bitty battery and expect it to do what this battery does or this battery does. Now, as you can see, that's the primary energy that we've used compared to what our energy output is. So if we do this long enough, we can get a gain and we can get a COP rating. So now if we disconnect this.
It starts jumping up immediately.
Right. Right. Because it's recovering.
Right.
It holds it in a locked condition, and it's going to maintain that current level no matter what you do. And so you can see here that our ending curve is about 14.2. It's going to come down. You know, it's going to come down to the level where the battery wants to sit. So basically, those are the three modes of operation of the machine that's not fully understood. And now it should be very well understood of what you can do with the machine once the machine is put together right. And once again, I'm going to point out no neomagnets. You don't need them. It's not going to help you. It's going to hinder you. Don't make any alterations on the circuits. That's going to hinder you. It's already been figured out that this is where it runs. And you can see that it runs with all these different devices hooked to it. What I thought I would do is recap all these circuits, and starting with the simplest SG, and basically this number one circuit was the original schoolgirl motor, with the exception that the recovery diode and the secondary battery was not there.
Okay.
So basically this is exactly what all the circuitry was that was in her little motor. The only exception being that she used a small signal device transistor, a 2N5885, instead of the bigger power transistor. And in the second circuit, which has never been a part of the projects from the original SG circuits that are on YouTube. So all variations of the SG circuits on YouTube are nothing more than this circuit here.
Okay.
The very first circuit as you've seen it draw, as it's drawn right here. All right? Now, one thing to point out is this circuit has never been shown until now.
That's the forced charge circuit.
That's the forced charge circuit. And this circuit has really never been drawn or shown, or the values ever shown till now. In other words, the comparator circuit is a totally different circuit. The way I build it, there is a company building one which is licensed by me.
Okay.
And if you have to run a comparator circuit, then I would suggest that you start out with this basic controller that's built by Eric and Tom Childs and John Korn, because this is going to allow you to do a lot of different things. It will allow you to protect it. It will allow you to try many different experiments, and plus the circuit's given to you.
Okay.
So if you burned it out or did something like, you could repair it. My circuit, I'm going to tell you right now, that is basically a heavy-duty circuit, and I'll just grab it and basically bring it into view here. And in the one that Energetics built, there is no protection because we don't want any protection in it. But the only reason that we haven't released it yet is there's not an understanding of how to work with this circuit yet.
Okay.
And this is what I'm trying to bring out here, of what has to be done.
So this is the same as this one here?
Well, this is the same as what we're using right now, right? And the only difference being is there's 4 large capacitors, 15,000 microfarads each, and they're in parallel for a total of 60,000 microfarads, which is a lot at 80 volts, if you bring it up to 80 volts. And so, of course, you see 5 FETs at 16 amps each in the back of this comparator. And that's located right here, as we explained it. This curve here allows you to adjust the trigger level at the voltage that you want. So what you're actually adjusting to the secondary battery is the amount of current that the battery is receiving under charge.
So that is a much more simple one of these?
Yes, this is very simplified compared to what I was just showing you.
Yeah, okay.
The one that Energetics builds, which you can purchase if you want, is potted, and you adjust it one time to wherever you're going to use it. And it's not made to put a power supply into. It's made just for the SG machine. So
last night when you were adjusting this is all going to be potted, so you wouldn't be able to make those micro
no, you can make the adjustment.
Okay, you can.
That's left so that you can do that.
Okay.
I'm just telling you that there's no warranty on it.
Yeah.
Because we have no control if somebody's going to put a power supply on it.
Right.
So therefore, there's no guarantee on it.
Right.
It operates when it leaves here, and what you choose to do with it, you do with it. So you may purchase it from Energetics if you need it. And so basically, these are your 3 circuits. Circuit number 1, schoolgirl, simplified. Revision A, dual transistors, all the way up to 30, if that's what you need to do. And then the comparator circuit. Now, one thing I'm going to point out to you is these arrows indicate the phase of the device. So everybody knows that you're going to need a positive signal to trigger this transistor on. At that point in time, it's going to pull down because it's inverted here. So down here is drawn a little phase splitter explaining to you a little theory of how this is actually operating.
Yeah, okay.
And as the coil flips around the other direction, then the discharge occurs and the voltage goes to the battery. However, if you choose to make a massless current, then you would find yourself with a resistor in here, and then you'd be summing this like you see right here, and then this would be a delta 0, and what you would see is a signal that's just spikes. Now, point out again, in red, do not use any neomagnets in any of these motors, because if you do that, you're going to saturate this core, and you're not going to get the same as what John got here on the bench. Do not make any changes until everything runs. A good starting point is between 680 and 470 ohms on the basis of these transistors. You start there.
Okay.
Don't go too low and don't go too high, because you want to be in a range where the only adjustments that you're using is exactly what you've seen in the motor on the bench over here, which was a series resistance with the base resistance right here. And you saw my series resistance was 12 ohms. And that was to balance out the motor to get the highest speed with all the devices. Now, the kit circuit board is also, you may purchase that. And also Eric and Tom Childs builds a simplified version of this.
Okay.
So that you can start out with a basic machine. But basically that's the kit circuit board. And that covers the things that you didn't know about the SG. You did not know about 1, 2, 3, or 4. All right, and there's nothing that covers it better than the way I'm doing it. Because this is the way I want it to run. This is my concept of it. And so, who knows better than the inventor of it? And so, basically that's what I have. Right here. And do you feel to need to do anything else here, Pat?
Not really.
I think you covered the bench stuff pretty well already, John.
Yeah.
So,
is there anything? Oh, one other thing to cover. Very important. And so I'm going to let the camera get a shot of this. I'm going to back out of the way, and then I'm going to erase this.
Okay.
And I'm going to show you the way that the motor, the condition that this motor is actually running, and I'm going to explain the difference between the two.
Okay.
Okay, what I'm going to